It is a world full of fear and worry for many of us, but nature is reasonably kind, and goodwill is a common human trait. There's beauty, lawfulness, and progress, all of which appeals to man the thinker, if not always to man the animal. However, ignorance, superstition, and loyalty to myths have darkened our views of the universe. Fancy how far we might have gone if we had not been shackled by mythology. We occasionally venture to the borders of science to seek deep answers and to think deep thoughts, in the hope that man will contribute something more to the future ages than his fossil skull in the sedimentary rocks. Modern man should now interpret the nature of the universe more rationally than Moses could, or Spinoza, or Locke, or Pascal, whose cosmic outlooks were of limited range. We've gone very far in the accumulation of verifiable facts, and this we must remember: there will be, if we remain civilized, no return to the old superstitions. We must learn to live with our newly acquired scientific ideas. We shall adopt from the beginning the attitude of mature inquirers and confront the cosmic facts squarely and fully. It will be small but magnificent man face to face with enormous and magnificent universe. As scientists and dreamers, we are curious about man's place in the plan of the universe, curious also about the planning. Is man in a commanding position in the universe? Or is he in the ranks, tagging along, forgotten of the stars from which he sprang? Is life a local operation confined to the surface of this one planet? Or is it a widespread activity? Our search for man's location is built around the four basic qualities or entities which make up the physical universe. We search out our place not only in space, but in time, in matter, and energy. We shall take a journey through the depths of space, starting in the world of the electrons, traveling out through the metagalaxy, from the nearest to the farthest, from the smallest to the largest. Have we come now to the end of our journey through space, or are there other steps ahead? Stars, star clusters, and clouds of stars are congregated into the great cosmic units called galaxies. A galaxy is a million times the size of an amoeba, and an amoeba is a giant compared with the electron. The number of stars now within our scientific knowledge is not only the 5,000 or 6,000 naked eye objects of the ancient Hindus and Greeks, nor the million stars revealed by the small telescopes in the days of Galileo and Newton, nor the few billions of a generation ago. The number of stars in today's surveys is more than 100,000 million billion, and each star radiates the fuel for life to whatever planets go along in the journey through the depths of space and the eons of time. The time element is everywhere in the panorama of the universe. There are many kinds of clocks and calendars, all tuned to our various needs. The clock on the office wall is of no use in the laboratory. The intervals are too coarse for timing the electrons and too fine for the rotation of galaxies. The vibration period of an ammonia molecule is less than 10 million billion than the period of rotation of a spiral galaxy such as the Milky Way. The most useful calendar for finding man's place in cosmic time is the calendar of geologic eras, or the geological timetable. Turning our galaxy back some 25 rotations takes us to the turbulent planet-breeding times when our Earth was forming. For 3 billion years, the Earth was essentially barren biologically. Now suppose we reduce the remaining 2 billion years of Earth's history to approximately 7 minutes. In our shrunken scale, each pulsation we see and hear then represents a span of 5 million years. Probably the first simple life forms came into existence in the early days of our expanding universe. Thanks to organic evolution, simple organisms became complex. Amoebae, bacteria, bryozoa appeared, and numerous one-cell organisms that were neither plant nor animal. The flow of time, as the galaxies rotated, brought forth many curious structures that did not survive against the rising and falling of the mountain chains. The shallow seas, full of life, were rich places for the developing of the biological experiments. They were simple organisms, scarcely more than big molecules emerging from the gases that made up the primitive atmosphere of the Earth. The gases included methane, ammonia, water vapor, and hydrogen gas. Energy and much time were necessary for this evolution from the lifeless to the living. And energy and time are what existed in abundance on the primitive Earth's surface. The energy was in the forms of radiation from the sun and from bursting volcanoes. It was the hot radiation from the breakdown of radium and uranium. And of most importance, the energy source was the lightnings that flashed through the primitive atmospheres. With help from our star, that is, the sun, we have slowly evolved from the wonder-working archaeological ooze in which so many biological experiments have been made. We have risen from the hot, thin soup of the shallow seas, from which also evolved bluebirds and roses, and a million other wonderfully constructed organisms. When the trilobites dominated the shallow seas, the galaxies were much closer together than they are now. In the earliest days, vegetation began to take part in the evolution of the Earth's atmosphere. For the green leaves, through Operation Chlorophyll, absorbed the carbon and released the oxygen to our atmosphere. Our atmosphere changed from one dominated by hydrogen to our present atmosphere dominated by oxygen. We salute the biological winners in the contest for continuous existence. For example, the algae and the mosses. We try to understand why the losers lost. Losers such as the trilobites of the early Paleozoic and the dinosaurs of 100 million years ago, and Neanderthal man.
How do you know what all things are? Daddy told me. What are they? Atoms. Everything in the world is made of atoms. What are atoms? They're all elements. Oh. Oh, an element. I know those things. Can we build with them? We're going to build the bridge. How many elements are they? A little over 100. Oh. I understand that in real life. Are all the things made of atoms? Yes. Am I made of atoms? Yes. Is the moon made out of atoms? Yes. Is the earth made out of atoms? Everything there is made out of an atom. Oh! How do you know I'm made of atoms? Because Daddy told me. Oh. What did Daddy tell me? Because I don't know. Because he doesn't like me, that's why. That's not why. Sure it is. Let's make a building. I'm going to try something. Just to see if what can do it. Want to see me make water? Real water? Get me an oxygen one and get me 2 hydrogen ones. These kinds or these kinds? I always have trouble. This kind of yellow or straight yellow? Straight. Oh, what is this one? The green one. Carbon. Carbon? If you want to see a carbon, okay. All right, I'll make a horse. It would be too complicated to make a horse. I'm making a horse. Why you shut him? Why does this keep on falling? Are those real atoms? Oh, they're just blocks. Here's some water. You're right. Did anyone ever invent energy? Or did someone use it for a very special cause? Nobody invented it. But Einstein, it was his theory, he discovered it. What was his name? Einstein. What does E equal MC2 mean? I don't know. I'm not that smart. What is energy, though? Well, energy is a force. If I took some matter and I threw it the speed of light, yeah, it would become energy. Oh, that's better. Because energy is my strength.
Yeah, you're using all your energy.
Oh, not all of it.
Haven't you ever heard, if you took a little energy and you slowed it down, then you'd have matter.
Let's get off the subject.
They're different, but then they're the same, only in different forms.
Can I tell you something? Matter just is less than your energy. You don't take as much energy as you do in the matter. I mean, as you do in the energy.
It's the same, and it sends off radioactivity in terms of energy.
Oh. Now I see. Some things, you just get them as you figure them out.
Our existence, our warmth, and food all depend on energy from the sun. What can be the source of the solar power that radiates energy into space at the rate of more than 4 million tons a second, and yet does not exhaust itself over the millions of years? The sun, deep in its interior, transforms hydrogen into helium and radiation, thus providing abundant radiant energy. The major part of our knowledge of the universe has in the past come through information provided by one sense organ alone, that of vision. Our eyes are, however, sensitive only in a small segment of the long radiation spectrum. They are sensitive from the violet to the red, over much less than 2 octaves. But we have now learned to explore nature with radiations extending over 50 octaves, extending from wavelengths measured in miles to wavelengths of less than a billionth of an inch. The invisible ultraviolet has become a tool of industry and medicine, and an aid to research into the nature of molecules and of biological cells. The radio, radar developments and the explosive energies of the gamma rays have created a new culture, the atomic civilization. In a few short decades, the exploration of the entities, energy and matter has changed the way of human life. Less than 100 years ago, chemistry went to the heavens, and man was suddenly in material contact with the sun. By means of the spectroscope, the light of the sun has been chemically analyzed. More than 60 of the 100 kinds of atoms known on the Earth's surface register also in the solar spectrum. As far as we can tell, the same physical laws prevail everywhere. The same rules at the center of the Milky Way, in the remote galaxies, and among the stars of the solar neighborhood. 100,000 of the brightest million stars are essentially identical with our sun. Everywhere the same physics, the same chemistry. If we attempt to locate ourselves in the world of energy, man and his works are of minor consequence. But there should be nothing very humiliating about our being inconsequential. Are we debased by the greater speed of the sparrow? The larger size of the hippopotamus? The keener hearing of a dog? No, we should adjust ourselves to the cosmic facts. It is a magnificent universe in which to play a part, however humble. In the category of matter, we can claim a much better world position. We have the distinction of sharing a wide variety of chemical atoms with the greats of the universe, with inanimate planets, with radiant galaxies and cosmic dust. Man, in a sense, is made of star stuff. Man's concern with his own future as an individual is instinctive and is often intense. But his concern for the future of the species, Homo sapiens, is now slight. To me, it is a sign that we are approaching maturity when we inquire what lies ahead for mankind. What lies far, far ahead in the times when the galaxies will have scattered, the moon receded into its coming faintness, and the massive mountains will have been worn away by the persistently weathering winds and rains. Will man then be one of the Earth's inhabitants? Any insistence that our moment in the geological ages is somehow enormously significant should be questioned. If there's some grandeur in our position with respect to matter and energy, space and time, I fail to find it. We must look elsewhere for an appraisal of our true importance. Once we've cleared away our illusions about man's worldly significance, we are better able to ponder the meaning and scope of life. We ask, what is life? And we ask, are there the likes of us elsewhere in the universe? In this structure of stars, space, and time, are we alone? life is varied. There are over 1 million species of animals on the Earth. Animals and plants all employ the common atoms, although the percentages vary. More water in a jellyfish, more silicon in a snail, more calcium in a bony vertebrate. A common technical definition is that life is the activity of a giant molecule reproducing itself. Life also is tough, tenacious, and persistent when we give it time to adjust to changing environments. Life on Earth has wide adaptability, but there are limits. Life cannot exist in the extreme heat of a star, nor on comets, which are too thin to hold an atmosphere. No life on meteors. They're too small for liquid water and too unprotected against the deadly ultraviolet radiation of the hot stars. In our search for life, we're therefore left with the planets. Only on a planet's surface can we expect to find suitable conditions for life. Planets on which life can emerge must be neither too near their suns nor so remote that the cold is unrelieved. They must not be too small to hold an oxygen atmosphere. They must have salutary waters and agreeable rocky crusts, like our planet Earth, which is number 3 in the family of the Sun. The fact that life started on this undistinguished planet, on the Earth, and succeeded in holding on and growing here naturally is by itself nearly enough assurance that life is a cosmos-wide occurrence. No field of inquiry is more fascinating than a search for humanity, or something like humanity, in the mystery-filled happy lands beyond the barriers of interstellar space. But are there such happy lands? As unsolicited spokesman for all the earthly organisms of land, sea, and air, we again ask the question, in this universe of stars, space, and time, are we alone? Let us say that 1 out of 1,000 stars are like our sun, a single star. Double stars, stars in the centers of globular clusters and exploding bodies, have no planetary families. Then suppose that only 1 out of this 1,000 single stars have planets orbiting around them, And perhaps only 1 out of that 1,000 have planets at the right distance for moderate temperatures. And perhaps only 1 out of that 1,000 of 1,000 have planets large enough to hold an atmosphere. And of them, only 1 out of 1,000 has planets with a proper chemical composition for life to emerge. The disqualifications have been ruthless, a gesture to those who harbor the wish that man has the distinction of being unique in this universe. With that reduction, however, 1 in every billion stars will have a crusted planet entirely suitable for life. But 1 in a billion is not at all scarce in the overall stellar universe. Exactly where those other life-bearing planets are, we cannot say, lost as they are in the glare of their stars, isolated as we are in space. But statistically, we deduce the existence of 100 million of them, planets with highly developed organisms that live and react to their respective environments. No, we are not alone. The cosmic immensities should not dismay us. In our natural program of growth through understanding, each day competes with its yesterdays. We grow naturally with the passage of time, as do the animals and plants. They also make the effort through adjustments and improvements to survive and grow. But this automatic, slow, slight, and hesitant rising is not enough for us. We can consciously speed the development. For us, it is not growth in size and strength or in age, but growth in the qualities we associate with the mind. The development that includes those fine indefinables, heart and spirit. We who read and write and contemplate have minds which have been laboriously taught, whereas many animal species, for example, the houseflies, are born with their training complete. Our intellectual sensitivity differs only in degree from those of other earthly organisms. And naturally we wonder if other organisms, basking and groping in the light and warmth of some happier star, may not have succeeded better than we in the search for the whys of the universe. Since men in the future must continue to rely on their wits and acquired wisdom, and cannot depend on a built-in generic mind, we wonder whether proud man or the meek will eventually inherit the earth. As an example of the meek, let's choose the fish. They employ instincts and not heavy forebrains. Which animal type will be here 10,000 years from now? Homo or the fish? The adjusted fish or the maladjusted man? No foreseeable collision of Earth and stars in the next 10,000 years. No fear of the sun growing too hot or too cold. No danger of the Earth escaping from its present orbit. No fearsome changes in climate are ahead. Man seems to have a healthy prospect. But there is one danger. That danger is man himself. He is acquiring tools and studying techniques that might succeed in the complete elimination of mankind from the planet Earth. It may be, however, that the men of the future will overcome our shortcomings and build out of our thoughts and acts a finer mental and social structure, one that is in better keeping with nature's heavy investment in the locally dominant human race.